Everybody can hear me. Hey guys, 1 second, we'll be right back. Hello folks, how are you? This is Mark D'Antonio here, live from Arizona. I'm here with our friend Daryl Mason, who's not here. I'll tell you about this guy in a second, but hey Daryl, how are you?
Well, Mark, I'm good, thanks. You? Hello, Bill.
Hey, and that's who it is, that's correct. This is Bill Skywatcher next to me here.
Hello, Cat.
This is his first trip to Arizona.
Yes.
So Bill is joining us here. Bill, you having a good time?
Awesome.
He's having an awesome time.
Except Mark decided to show me a scorpion.
Oh yes, I showed Bill a scorpion tonight. We went hunting for scorpions out in the yard here.
He's a big kid, people. He's playing with it, like trying to tease it, and then it runs into a hole.
It did run into a hole. That was I didn't expect.
But what if it would have ran toward me?
Then we would have had a hell of a lot of entertainment.
Oh my gosh.
Of course, he hasn't seen a tarantula yet, and the tarantulas out here are the size of the palm of your hand.
Oh, God.
And they're just gorgeous little furry creatures that go crawling all over you.
No thanks.
In the middle of the night when you're not paying attention, they crawl right up your body under the covers.
But folks, I don't know if you could see it. You see what's on that shirt right there?
Oh yeah, I gotta show people this. Bill and I are a match set. We have the SkyTour live stream. This is the SkyTourLive.org STLS official shirts. Bill's got one, and on the back, he's going to show you.
Can you see it?
A little bit. It's the Roswell Nebula, and it says the universe live in real time.
Can you see it now?
Yeah, and they can't. Let me enlarge a little bit. Just sit still for a second. Right here. Okay. There you go. Universe live in real time. Now it is backwards because I've reversed the image so I can point to certain things as I need. But that is the...
they're super comfortable, too.
Oh, yeah. These are really, really soft shirts. And they're available to anyone for a $25 donation to SkyTour Livestream.
But Bill was the first one to purchase one. I just want to say that.
He won't stop talking about that.
I'm going to rub it in.
Get out of here.
I'm going to rub it in.
He doesn't stop talking about that. Well, that's okay. You know, it's his first trip out to Arizona. So, trying to make it memorable. And I just want to say hello to Marianne, who's hanging off in the wings. Come over here. Have a seat.
Hi. Hello, Marianne.
There's Marianne.
Hi, everyone.
This is the studio that Marianne actually does UAPPD,
but I Detective.
UAPPD and I Detective on KGRA. KGRA is I Detective, and then UAPPD is the unknown anomalous phenomena as seen by the PD. And she's got a really, really good. Organization she started. Here it is, the UAPPD T-shirt.
Yes.
The SkyTour Livestream ones are better, but I'm kidding.
They are wonderful.
I'm kidding. So yeah, as you can see, this is the moon. This is the just past first quarter moon. It's good to see a bunch of people here already. I want to welcome Tim F. It was the first one here. Hi Tim, woohoo! All right, Michael Galea is with us tonight. Izabela, hello Izabela. Alice Pooper is with us. We've got Cosmic Ray. We've got who else is in here now? I just saw somebody else in here that I hadn't seen before.
Can you widen that to see?
Oh, Michael Hedrick is with us. Yeah, Michael Hedrick's with us as well, and so I just want to make a slight adjustment here. There we go.
There we go.
Yeah, so it's good that you guys are with us tonight. And Bill's joining us too, okay, because Bill,
Yes,
of course,
he's gonna sit
is out
here.
here because we're
Sure.
actually we're actually going to a Roswell on Thursday to do talks. And I'm going to do a talk on UFO propulsion, which is based on some actual physics. And Bill is going to be managing the KGRA presence there, I believe, right? Tell people what you're going to do.
Well, I'll be at the KGRA Digital Broadcasting booth. And after those that do the speaking engagements, they're going to come over to the table. I'm going to interview them. So hopefully he'll be coming over to the booth too to be interviewed for
I will. That's
10 to 15 minutes.
Nah, nobody wants to hear me talk anymore.
But the highlight is Saturday night, because...
Oh, yes. That Saturday night, we're doing a live audience event, SkyTour live stream, from Roswell, where it all began. So that'll be kind of cool.
Now, Roswell is mountain?
Roswell is an hour ahead of us.
Yeah,
so
so
when it's 9:30 here, it's 8:30 or 10:30 there.
10:30 there.
Yeah.
I think so.
So they're ahead of us. So we're going to be starting at 9:30 Roswell time, and so that's 8:30 Arizona time.
Right.
And I was in here at 8:30 tonight, and it's actually pretty dark, Daryl. I checked it out. We could see stars, and it's still a little bright, but it was actually not that bad. So we'd be able to check out M101, for instance, and every night we're going to check out Mission 101 to see how the supernova is going and check the status of the supernova. So I think that'd be pretty good. So
Good deal.
yeah.
It is amazing how Mark is able to stream at this moment, how compact and incredible it is, the equipment that he's utilizing right now. He's got 2 monitors. Everything here can fit in the backpack. I'm not even kidding.
Yeah, it's a backpack. I flew it on the plane to get here, actually. And I came in today at 11:04 this morning. And I had everything in a green backpack that we're streaming with. The computer's this little tiny mini computer, it's called. Yeah, everything's in that green backpack. And my laptop's in there even.
It is.
So, very compact.
Can I say one quick thing before I go to bed? I want to say hi to Heidi. Gad is listening, and she said that her daughter, Lily, really loves the stream. So we love having the young people like Daisy and Zoe.
That's right. Daisy and Zoe have Lane, who joined us from time to time.
That is so great having the young
Elisha
folks.
Vieira's has
It's truly
Darlene.
educational.
Yes,
it really is.
very. So Heidi, I'm so glad Lily's here.
Darlene
watching.
is Elisha Vieira's
Yes.
daughter, and she bought a book for her daughter.
Yes, she
and
did.
Her daughter was reading my book in a story online. It was really cute.
That's cool.
Yeah,
That
I
is
thought
so
that was really
perfect.
fun.
So I'm glad.
Hey, I think that's pretty cool to
Yes.
see
Yes.
young people excited by this. And it's for everybody, It's for everybody. And by the way, make sure you check out our Etsy store. It's up there at the top. It's called SkyTourShop. So go to Etsy.com and search for SkyTourShop, all one word. And you'll see, almost 90 products that we have up there now that are, all in support of what we do. We just need to be able to keep doing what we're doing. And, the internet costs us money. And at the risk of sounding like some kind of, public television telethon, I apologize for that. I know, but you know what? You got to. You have no choice. It costs us $110 a month for the internet, and we have one location now.
What's that, Starlink?
2 locations
Yes.
coming up in the next couple months, and then there'll be a 3rd location. Probably a couple months after that. Well, we have the existing telescope for that already. That's the East Coast side, and we're going to be putting together a portable system out there. So. That was going to also require internet. So it's kind of important that we have some kind of assistance if you can.
But if they, this is separate with the shirts, if they donate $25, where do they go to? What site? Where can they donate $25 to get a shirt mailed to them?
Well, actually, if they want to, that's a good question. Marianne has a thought.
Yeah,
about
Marianne.
My thought is, guys, if you're looking for a shirt, which these are really amazing shirts, and we should have dark blue coming up in the near future. If you can, go to SkyTourLive.org, go to our site, and then go to where it says Contact Us. Please send us your name, phone number, and we'll contact you. Right now, we're taking cash and we're taking Zelle. Would be another way that you can send us the money, and it is a tax write-off. $25 donation, and we'll be more than happy to send you of course, your T-shirt, letter, because it is a tax write-off for you.
You should get a letter saying it's a write-off.
Yes.
Yeah.
That's cool. It's tax deductible.
Yes, very much so.
Is there a possibility
It's a
to give
donation.
me an ice? I need one. Thank you, Marianne.
Could you do me a favor? Hit the arrow down so we can see what
hello.
they're saying in chat. There we
There
go.
we go. Here's Heidi Gad. Hey.
There she is.
Hi, Heidi. Haven't talked to you in a while. It's nice to see you.
Eric's in there. Warren's son.
Oh, is Eric here?
He's a big fan. You know what he said to me?
Where is he?
Damarinolo. Do you know what he said to me? Bill, throughout the whole thing in Roswell, there's one point that I don't care. Nobody's going to interrupt me. I got to go sit in and see Mark's presentation. I'm not kidding. He is a big fan of yours.
Well, yeah, it's really nice. Eric, of course, is with KGRA.
Head of ops. Head of
Yeah.
operations.
Yeah. Oh, there's Domarinolo.
Damarinolo.
That's Eric.
Yes.
Hey, Eric. I'll see you in, I guess, a
Couple
few
days.
days in Roswell. Thanks for coming in, Eric. It's very nice to see you. And then let's see. Calabos is with us. Hey, Calabos. He's saying still using my Starlink. Yeah. Yeah, I know. I want to see the next Starlink units because right now, where we are... Oh, hello, Kathy. Right now, one of the things that we're doing is we're using Starlink, but it's actually what's considered a low throughput location. So we don't have a lot of satellite coverage, unfortunately. So we actually have to pay more per month than the people that have higher throughput. That doesn't seem to work for me. It doesn't make sense, but that's the case. So it's just crazy. Kathy Printer6 says, I can't stay long in Anahata 77. Hello,
It's
Bonnie.
East Coast time over there for her.
Yeah.
So it's kind of getting late for her. Almost
I know.
1 a.m.
Yeah, usually I'm starting about a half hour before this when I'm on the East Coast. Right now I'm in Arizona, so it's 3 hours off. But it's so nice to see you guys. And yes, we have the moon in here, but we're going to take a jaunt up to another object that I've always liked to look at. And
That's cool seeing her from this end. I got to be honest.
Oh yeah, this is different, right?
This is different.
You're seeing the
Just
entire.
seeing how you operate
You're
it.
seeing the two screens. Bill's seeing the broadcast side of things for the first time. He only sees what you guys see now
Right.
on the screen, which is over here. Okay, he doesn't ever see
This side.
the broadcast side where everything's going on, with the chats going and everybody's talking and everything. He doesn't get to see that. And Calabo says V4 Mini will fit in your
Where are
backpack.
his shirts?
I actually have
Where's
a.
the bunch of shirts? I want to show them the roll.
What's the
when
name
it
of
comes
this
in.
guy? I have a Ryzen 5 5600, and it's 512 gigabytes SSD with 16 gig of RAM, and it does everything I need.
Powerful.
And it's a 5x5 by 2-inch thick box. You know. Oh, Bill's gonna show. Yeah, these are what you get for $25. Looks like a little telescope. Thanks to tarantulas, she created this beautiful wrapper, and then inside of it is a T-shirt that she put in there, and it's one object image. It's the Rosette Nebula. Okay, we have more, and the image on the front indicates the size. Right?
Yes.
And this one here is a extra large. It's a large.
Large.
The Helix Nebula means it's an extra large, and so the different images say that. So I have a feeling that you guys might have a fun time. So I think that that's up to you. Make sure you go see the SkyTourShop on Etsy and buy some of our stuff up there if you like. And I'll tell you, everything that's up there, we've purchased one of these things already as a sample just to make sure they're going to be good. And if they're not, then it's something that we haven't purchased before. So we have almost 90 products up there already, from shoes to bathing suits.
I was gonna say the bathing suits. I couldn't believe it.
Bathing suits, shoes, socks. Okay, hey, everybody wants Horsehead Nebula socks. You know, and we got a lot of stuff. You know, and mugs of all kinds, mouse pads.
Not for nothing. What a stocking stuffer that would be.
I know, huh? And lamps. We got lamps.
That's so cool.
Desk lamps with the shade as different nebulae that you might want. Oh, it's just so crazy. We're having such a good time with this. It almost gets out of hand. It's almost like I'm doing too many things, you know. But you know, it's okay. Let's go do a search now. Let's go check out Messier 101.
That is so cool.
There it is. So Messier 101 is there. So we're going to tell the telescope to go and do that now. Go check it out. So you'll see the telescope over my head here moving. There it goes. It's on its way. And if we come in here, we'll go into what we call our night vision mode. All right. And I'm going to take us down, or back to, I should say, 1 second here. So this is a 1 second night vision mode. You don't see anything because we're only going at 6 milliseconds right now for exposure.
That is.
And now you can see that we're moving stuff in. So there we go.
Types in wherever he wants to look, and the telescope moves right to it.
Sure. I mean, it has to happen that way.
Yeah, that's the whole point.
This bright thing here, when the moon's out, you know, we have a calibration thing where we're actually flattening the field, and so you're seeing an incorrect set of values here, but that's okay. That will change. I could actually just remove it for the time being and show you what it looks like without it.
Wow.
Okay, so that's what it looks like without it, and that's something that see how bright the moonlight is, because we're actually, you know, the moon is pretty bright right now. All right, and let's actually do a 10-second shot here. I hear Daryl typing away.
Oh,
He's
that's where you
talking
do
to
the
people in
exposure.
chat. Yeah, that's the exposure. 10 seconds, and then I'll do a stack, and I'll clear the last one. All right, and so this one will clear. Oh, Daryl, I had the Epley maneuver done. Did you mention that?
Yes.
Yeah, I had to do the Epley maneuver because I had calcium carbonate crystals that caused my ear to go out of control. I literally lost my balance. I literally practically fell down. It was just terrible.
Fantasy, I'm here due to the hospitality of Marianne Robb, who's just simply an amazing human being.
Once in a while. Yeah, she is.
And we're right here in her home in Arizona. Mesa?
Mesa.
Mesa?
Yeah. All right, so that's what the galaxy is.
Wow, you could see it. You could see the
Oh
spiral.
yeah, well you can see the supernova right there. Okay, and one of the other things you don't see is that I can actually do this kind of thing. I can.
Has that gotten brighter over the last couple of months?
It's actually gotten dimmer. See, this is the supernovas inside that red box.
The supernova was down to magnitude 11.8 as of last Friday.
Yeah, Daryl says
had
the
been up around
supernova
11.
is down to 11.8 magnitude. So it's fading.
So what was its
number
peak?
is fainter.
What was its peak?
I think its peak was a 10.8. Daryl, do you remember?
Okay.
10.8 or 11, depending who you talk
10.8 or
to.
11, depending who you talk to. Yeah. So what I'm going to do is I'm going to get out of this, go back to my night vision mode, and move this galaxy more toward the center here, because I'd like to actually center it up before we do this. So let's do this, and then this, and I'm going to move this up here. So we're going to head a little bit west.
Oh, that is so cool. How you're able to toggle it like that.
Oh, yeah. Okay. All right, so we're moving over a little bit. Now the supernova, even when the moon was out, the supernova shows up brightly in our image. Okay, go over a little more, and then take the telescope a little south, and bring it up into the center.
Rivers from Belgium.
Wow.
Okay.
You have a viewer from Belgium.
Oh yeah, we have Django.
Yeah.
Yeah, Mr. Django from Belgium. He comes in most of the time. I think
Cool.
it's great. All right. And I'm going to drop us down just a little bit. I think I might have gone a little too far.
So that's like really ultra sensitive when you're hitting.
Yeah, actually, you know what the thing is? I've got to increase my gain. So I'm going to go to 200. It can get really bright for a second. And then I'm going to do this. And you'll see the change. You'll actually be able to see the galaxy in here somewhere. Oops, hang on.
By the way, I get a kick out of sitting right next to Mark and driving him nuts and distracting him, just so you all know.
Nonsense.
He chased me once because
I yelled at
it's
you.
a long story, but he chased me down his driveway once.
I did. Remember that?
Yes, I did. I remember that.
Oh, yeah.
I'll never forget it,
You're
actually.
just like impossible. You do crazy things sometimes. Okay, let me, I think that's it up there. So let me just do another 10 seconds. Actually, you know what I can do? Very simple. Let me see where we're pointing. There we are. So that's where we want to go. So it's close. So I'm going to take this, all right, and I'm going to move us.
What's the distance from light years? This is
around 20 million light years from.
Wow.
So you're seeing it 20 million years ago.
Yeah, you're looking back in time.
Mm-hmm.
Wow.
I just want to go north, I think. So we're going to head to the north.
What's the oldest object that is viewable?
Well,
this is 20 million. So, like, is there something?
Well, for us to look at something that's
fast.
Marianne is standing next to us, and she's on her phone typing. Hello, Mazif. Mazif is with us. Kathy, I know you got to go. Thank you for coming.
Good night, Kathy.
And I think this way is the wrong way. I got to go back east. The oldest viewable object is really a class of objects. And that class of objects typically is something along the lines of globular cluster stars. They're pretty darn old. And so globular cluster stars are on the order of 12 billion years old sometimes.
Wow.
And they're some of the earliest stars the universe has created. And actually, for all we know about stuff, we don't know exactly how globular clusters form.
Wow.
Yeah. Let's bring this up and see how close we are. I may end up having to just reformulate here, so let's just do this. And I think that might be it. Let me just do a 12-second shot here again.
Mark, I think Bill may have been curious what the most distant object is, not the oldest object.
Oh, not the oldest. You mean the most distant object?
Well, wouldn't the most distant object be necessarily the oldest? No.
The most distant object might actually be the oldest as well.
That's what I mean.
But I have to. Yeah, that's where it is. Okay.
Oh, there it is.
Yeah. Let me. Let's just process this. I got to do a live stack. I'm going to get back to your question here in a second, Bill. That's a good question. The most distant object we've ever seen is the cosmic microwave background radiation. Okay, that's actually the most distant object. But it's sort of an object that's everywhere.
I think he means in your
space.
telescope.
Yeah, if you mean, and Daryl says, like, are you asking the most distant object in my telescope?
Right, the viewable viewable.
Well, we can view objects that are down to 17th or 18th magnitude, actually. And I've looked at 17th magnitude geostationary satellites with this telescope. So we could do that. There's the whole galaxy.
To Bill,
we'll
the
talk.
most
I mean,
distant things
we
we
got
see
a
in the
couple of
galaxy
hours,
clusters,
hopefully,
Bill.
but I'm also curious about.
And Daryl's answering a question. He says,
Okay.
"See, Bill can't hear you.
I can't hear you, so it's
Daryl,
difficult.
unfortunately."
Yes, I know.
I'm just explaining to them. We have distant galaxy clusters as well. Okay, and the Virgo supercluster is pretty far, but we've seen galaxies that are 80 million light years away. Galaxies that are 80 million light years away.
James Webb
Well, no, with our telescope.
or yours?
Oh yeah. And then but the James Webb sees galaxies that are literally so far away, they're moving so fast away from us that all of their data is shifted into the red and into the infrared, so you can't even see them. Look, we had 2 satellites go blasting through here. This one's probably a Starlink, and that one is something different. But this is our galaxy right here, and if we zoom in on that, you'll see our amazing little supernova. So just a sec here. Let's color correct as well.
So is that considered your typical spiral?
Yeah, this is called a grand design spiral. It's beautiful.
It's gorgeous.
It is a beautiful galaxy, and you look at this spiral, you see these arms are very clear. You see another object out here. You see some strange knots here.
Now,
and this right here, hold on a sec, let me just point it out, because we've been looking at this routinely every single night. Here we look. This guy right here, that object
supernova?
you see right there, that's a supernova. That's not this one at the top left, but this one right here, right there, that guy. That's a supernova. And Daryl, it looks to me like it's a little redder than it used to be.
Yeah, maybe. Sky and Telescope described it as yellowish last Friday.
Yeah.
I'll wait till you guys are done.
It was bright blue last time when we've looked at it over time. But it's actually pretty, it looks a little yellowish right
Awesome.
now.
It is awesome.
There we are.
Good night.
All right.
I'll see you in the morning before we go out.
So, yeah, that's pretty cool. It's
I have
looking
a
nice.
question when you're ready.
You can see these older yellow stars in the center and the bluer stars in this outside set of spiral arms.
When you see a tighter spiral,
Yeah.
does that distinguish age when you see something with...
Yeah, see, that was one of the things that they used to think. But the thing is, unfortunately, the winding up nature of the spiral does not tell us the age. You might think that maybe that it's a spiral that's more evolved because it's more wound
Yeah,
up.
because this one's wider, it seems.
Right. It seems right that way. But unfortunately, some of these galaxies that are more loose like this might actually be older than some that are more tight. But in general, the reason this happens is because we have now this quantity to explain why these galaxies, as you see right here on the screen, they spin almost like a fixed rigid disk. So these parts spin not quite as fast, but nearly as fast as the stars going around the center.
Could they have...
And that's called differential rotation, and they do that. So,
but could that have been influenced by another galaxy pulling it like that, stretching
absolutely. In fact, we know, like right here, Daryl's pointed this out too. You look at this arm right here. Okay, you see how it's got a crook in it right there?
Yeah.
Well, something caused that crook. Now, what could have caused that crook? Well, we know that when we pull out of the galaxy here, we see that there's another set of galaxies up here and here. Okay, there's another one that we just looked at down here, right there.
Yep.
Maybe that had an influence on it. Daryl, if you want to add to that, you can. I'll relay it.
Yeah, and the arm over at where the supernova is from about 6 o'clock up to about 10 o'clock.
Right here.
Yeah, that one's distorted even worse than the one at the top.
Yeah, this arm is distorted a little bit, but then this one's got a distortion in it.
Because it even looks... Yeah, it comes...
It was pulled way out.
Exactly.
So that being pulled way out, something did that.
Right.
So maybe this is a satellite galaxy, a dwarf galaxy that already passed through it, and we're seeing it as a snapshot in time, which is very possible.
So the galaxies travel different speeds. Like this one could have passed that one.
Well, yeah, these sometimes you've got material here, and galaxies have gone through each other and are orbiting, and then we get a picture of it at this point in our history, and we've missed a whole ton of the rest of the history.
Right.
You know, we don't see that history.
Yeah, you can show him that well with Messier 51, Mark.
That's correct, and maybe we can do that, huh? There's another galaxy that we can show you right now.
Wow.
Yeah.
To give you an idea.
He can see it in action.
You'll see the galaxy collision in action. All right. So let me color correct first.
Are the Milky Way in any way? Do you know there's another galaxy that could influence ours?
Yes. We actually have one heading right for us.
Really?
The Andromeda Galaxy.
And how many millions of years is that going to occur?
It's going to occur in maybe 2 billion years.
Wow.
And yeah, don't worry about it. You don't have to move
yet.
you don't have to move
2 billion years.
The Magellanic Clouds have actually.
So if we were to go out to
That's
the
true.
exoplanets,
what's that?
if we within our Milky Way, and we started going out to exoplanets, and we think that we need to go off-world, but necessarily that could be temporarily in nature because we don't know what the interaction with another galaxy would be in the future down the line, right? So that could be temporary in itself too.
Yeah, I mean, remember, everything's orbiting the galaxy. We've gone around the galaxy about 20 times since we were formed. Okay, orbited the galaxy. Okay, so we've gone through the spiral arms, continued on through, because that's a myth. You know, everyone thinks that everything in these spiral arms is orbiting the galaxy together.
Right.
That's not true. This is actually a traffic jam in the galaxy, and these stars are continuing to move through and orbit the galaxy. It's a hard concept to consider, but the reason we have spiral arms here is because of something called a density wave. And you think of it like a traffic jam on the highway. If you're looking down at a traffic jam from a helicopter and you saw a red car enter the traffic jam, it would sort of go through slowly through the traffic jam and emerge on the other side and keep going at highway speeds again. Okay? Well, if that red car that comes into the traffic jam slows down and then finally leaves at high speed was a star, that's a good analogy of how stars move around the galaxy. Okay? And and a traffic jam is a density wave. And so a density wave is a condition, temporary or otherwise, that occurs in the galaxy based on some interaction. We found that some galaxies passing through other galaxies create spiral arms. And one of the ones that I'll show you in just a minute, the Whirlpool Galaxy, is a perfect example of that. Because its spiral arms appear to have been created by the satellite galaxy that previously passed through it.
Wow.
Yeah, it's pretty cool. All right, I just saved this again to another location. There's our beautiful supernova for tonight. I want to thank you guys for joining us and coming out tonight and spending time with us. Hello, Gladys. I see Gladys is with us.
Yeah.
Gladys, he broke the fourth wall. I never imagined him outside of the office. Yeah, I'm in a different office tonight, and I actually have the background showing because Bill Skywatcher is with us tonight. He's here from New York, and I'm here from Connecticut, and we're both going to be in Roswell, and we're both in the studio for iDetective, okay, which is really interesting. So, talk about complexity, right?
And because of Mark's system now that he's using, he's going to be out of the office from anywhere.
Yeah, this is our portable system, our roadshow system that we're using right now. And it's really kind of cool. It's really, really nice. Very, very pleased with how it's operating.
Yes.
I'm actually thinking about changing over to literally streamline the large computer in the building to a tiny box and add 2 tiny boxes, one to manage the power to the building and one to manage the entire rest of the building. And I think that's what we're going to do. You know? So I think that's pretty cool. All right, let me go here, okay, because this shows our guiding right here. It's up there, you can see it. All right, there's the telescope in the building right there. Telescope control here, telescope computer, and that's the telescope in the building, as I said. And if I remove us, you'll see right here, that right there to the left, this is the telescope, another view of the telescope in the building right to my left here. Okay, so you see it kind of pointing up right here. All right, so that's another...
that is so cool.
That's another view of the telescope from inside the building. Normally you'd see it, but I had to go transparent on the, or solid on the background right now. Okay, because otherwise Bill doesn't show up.
Yes.
He's an invisible
It'll keep going in and out.
fuzzy blob.
Yeah.
Okay, so let's see. And what we'll do now is we're going to go back to our night vision mode. So I'm just going to, because we saved this a few times. So our night vision mode right here. There we go. And there it is, right there. Okay, now let's go to our planetarium. And we're going to do another find now on Measure 51. I'd love to look at some nebulae tonight, but with the moon's brightness, we may not see it as well. We can see them, but
It's bright up there.
not as bright, because unfortunately we have an issue with the moon. But I have the filters that can do it. All right, here we go. We're crossing over to the Whirlpool Galaxy to illustrate what happens when galactic collision occurs. So we saw a supernova, and now we have a colliding galaxy right here. And I'll bring that in to show you.
Mark, how often do you have to collimate the telescope to get it to stay focused?
The focus is done automatically down here. Right now, I already did a focus run on this, and I'm not using temperature compensation right now because I'm noticing the temperature isn't changing that much. If the temperature changes a lot, then I will. So suddenly it may suddenly start getting cooler out there, in which case the focus changes as the telescope cools. So then I'll worry about it.
Right. Not now.
Well, it's true. And what I'll do, though, just to show when we'll get into this in a sec, but if I come in here and I hit the button to defocus the telescope a little bit, you can see now that everything's fuzzy. See the little donuts? So what I'll do is I'll come back in here and I'm going to scan inward, and we're going to create a curve, a focus curve, and you'll see a perfect curve form, and then at the lowest spot in the curve is the point where the smallest image on all these sample stars has been located, and that will be the point of perfect focus.
That's incredible. That's awesome.
It's an autofocus, yeah.
Yeah, it's an autofocus.
Yeah. Yeah, so you can see the curve already starting to form. It'll get down into focus and then leave. Now, it's dropping by a certain amount, okay? And that certain amount may not necessarily be at the bottom of the curve, but it makes a curve of best fit, and at the lowest spot on that curve, wherever it may be, that becomes the number. So you can see that it's already coming down.
So we're talking over here?
Yeah, we're talking right. You'll see it. Okay, so it's probably going to come right about here.
Okay.
And
right, the two lowest points.
Well, yeah, it's going to be the lowest point. All right,
Okay.
you'll see that happen.
I see it.
There it is.
Yep.
Okay, so there's our lowest curve point.
That is so cool.
Yeah. And it's going to do 12 different samples. And I can set that to anything I want, but 12 is good. Then I'll say best focus, and now you'll see this sample curve go all the way out.
So it does it all automated, pretty much.
Yep, it is. So now we have a perfectly focused telescope. Okay, and so now we can actually come in and do a exposure here. Let's do a 15-second exposure on this, and we are at 200 gain. And we'll live stack this as well. When we do a stack, I've talked about this before. We do a live stack, and what it is we take an image, and then we take another image, align it with the first one, stack them together, and we make an image sandwich. And so all the faint stuff bubbles to the top.
Wow.
Okay, and you end up being able to see all the faint detail.
So how many do you need to put in the stack in order to be like a really vivid image?
So I don't know if you heard that, but Bill asked, like, how many do you do in a typical stack? Now, the answer to that is it varies, but you can do anywhere from 10 to 20 to 30. It depends on how far you want to go. All right. I usually like to go between 15 and 25, you know. And here, this is the curve. This white curve is the average curve for all the red, green, and blue curves. And this is the dark level. You bring that here, and it starts to cut off detail. Okay, and it'll solidify in just a minute. Okay, all right. But you can see some interesting detail in there. However, you lose some of the fainter stuff because the fainter stuff lies out here. Okay, and it's noisy because we've only stacked 5 frames. Okay, so as we stack a few more frames, this will become a lot better. You'll see a lot less of this color.
How long does it usually take for like that?
Well, it depends on the exposure. So as I said before, one thing that you want to look at, okay, is this right here is the exposure, and this right here is the gain. These are the 2 parameters in our control system that mean the most to everybody watching. 15 seconds with a gain of 200 or 250 means a great deal, because those numbers, you know, mean that we're going to expose the telescope for 15 seconds on the sensor at a gain of 200. If we do the same thing at 350, then there's a lot more noise, a lot more of this color modeling.
The
and
higher
it
the
takes
gain.
more stack data to remove that noise. So this is sort of a nice go-between, and the camera is way sensitive. Look at this
like
faint stuff out here.
But the higher you go with the ISO,
Yeah,
the more pixelated.
that's correct. Like as Bill's saying, he has a Sony, and there's more pixelation with higher sensitivities.
Yeah.
You know, cameras can be 200, 400, 800, 1600, 3200. You take a picture at 3200 and it's grainy. Take a picture at 200 and it's not as grainy at all.
Right.
But
it's not as bright. It doesn't bring out the features as much.
Right. That's right. Izabela, that buzz you were hearing is the air conditioning unit outside, because the temperature outside is still close to 100. And the temperature in the building is 26.75 Celsius right now, to give you an idea. And the building's 2 hours from here, out in the desert.
It's hot.
It's a little warm.
It's hot.
It's a little warm.
He loves it.
I do. It's not good for me, but I love it.
Don't worry, he's hydrating, folks. Making sure
I
of that,
am.
and he's making sure he's doing it.
I am. I'm not going to make them. I did make the mistake, and I ended up in a hospital.
Yes.
I took 2 liters of fluids when I was in the hospital, or 3. So it was actually pretty bad. Okay, let's...
Bill, you're seeing 2 galaxies actively interacting.
Thank you,
heck
Daryl.
no.
That's a good question there. A good comment. I pointed this out and then lost track of it to tell you. Daryl points it out. You're looking at a galaxy here and a galaxy here, and they're interacting with each other. You see how this spiral arm has a little point on it? Okay. If you looked at this from the side, it would look like this. One galaxy, that galaxy would have it'd be straight, and then it would go down at this point in the spiral arm where it's got that point on it right there. It'd be heading down. And that second galaxy out here, is down below it, down here. Okay? So as they interacted, it came through and torqued that arm with its gravity.
Because I see this little piece over here, though.
Yeah, because that's
interacting.
It's pulling that spiral arm from the galaxy down.
Down.
You know, it's sort of doing like this. You know, it's pulling that spiral arm
So
down.
is this a smaller one, or it's just more distant?
Well, it's
Or they're close to each
further
other?
into the page, okay, as we're looking at it, and it's tugging that material down toward it, and it's taking this part of the galaxy arm and it's warping it into the page down away from you. So from the side, it would look like this. Okay, the galaxy would be straight with a curve in it, as that disk is now warped down toward this other galaxy, which is now here. So it's gone through it and it's beyond it.
I have to ask you a stupid question.
Bill's gonna ask me a stupid question.
Do all spirals form in this like that? It looks more like a counterclockwise spin, or do you see galaxies spin in the opposite direction too with the arms.
Well, if you turned it over, which direction would it be spinning? If you saw it from the other side.
That's true.
It'd be clockwise from the other side.
Yes.
And the universe
It
doesn't
depends
know
how you're
direction.
looking at it.
That's how you're looking at it. Some are
Exactly.
edge on, some are one way, some are the other.
Right. That makes sense.
That's right.
That
So
makes
not a
total
stupid
sense.
question, but actually an interesting question. There we go. So this is the Whirlpool Galaxy, and it's actually this beautiful galaxy.
Beautiful.
Yeah, it's really pretty, and
Distance?
yeah, I was about to tell you the distance of this galaxy is about 23 million light years, I think.
Wow.
So, roughly, I mean, we can get the distances as provided by our planetarium program are sometimes wildly wrong. So it's possible that these distances are not correct. But,
Give me a second.
and Daryl's gonna get you the right distance here in a sec. Thank you, Daryl.
Oh, wow.
So I'm
this
gonna
is
go down
mind
to
blowing,
this.
actually.
Yeah.
No, 23.16 million light years.
All right, so 23.16 million light years. So you're seeing this galaxy as it was in collision 23 million years ago.
Right.
Undoubtedly,
what-
right now it looks different.
That's what I'm saying.
You know, and the difference might be something you could see, because over millions of years you might see a change, and it'd be great. But of course, you're looking at the universe, you're looking at a time machine. You're always looking back in time, always.
Yeah. This
So
one's a
whatever it
little
is
farther
now,
away
it's
than
happened
SEA
23
101.
million years since that image, from
yeah.
the time it takes for us to get here.
Yeah, and as Daryl just pointed out, you know, Measure 101 is 20 million light years. This is
Right.
3 million light years beyond
Right.
that.
So it's a little
Wow.
smaller looking, but it is in fact
And
a
that's
much
a true
smaller
telescope.
galaxy.
Look at these images. It's incredible.
This galaxy is a much smaller galaxy than M101.
This one is about 100 billion stars. Messier
Oh, yeah.
101 is about 1 trillion stars.
Okay. Daryl's got some data that he looked up. Measure 101, the one we just looked at with the supernova, is about 1 trillion stars.
Wow.
Okay. Now our galaxy has like 150 billion at the low end and up to 400 billion at the high end. You know,
This is a
so
trillion.
really it's kind of in between. We're like a training galaxy, you know. But the Andromeda galaxy also has over 1 trillion stars in it.
Wow.
So that's a very massive galaxy. So it's gonna, when it finally collides with us, it will tear us apart.
Oh my gosh.
But it ain't gonna hurt us. We won't know the difference. Nothing here will be affected. It just might mean that some of the hot young stars in the Andromeda galaxy might wander a little close to the sun system, and if they go supernova, it could affect us.
But is our sun going to make it that long? To the time this happens?
Yeah, because the sun's got another 5 billion years or so.
Okay.
So it's going to be like 2 billion years or
Right.
so when the
So it'll
Andromeda
be
galaxy
before our
hits.
sun.
Yeah. And when I say hit us,
Nova.
it's going to pass through us. It's not going to strike us and
Right.
well, anything like that.
Right.
But it's going to pass through us. Okay. So let's get rid of some of this blue here. Some of that green.
Can you zoom in on it?
Yeah, I'm gonna. Alright, so we're gonna zoom in now. Yeah, so now.
Wow, that's beautiful.
It'll sharpen up in just a sec. Actually, I haven't even done enhancement. Let me enhance it. I'm gonna add an enhancement. Watch the increase of the sharpness now of these spiral arms. Watch here. Look at that. Now you see all these beautiful blue areas of hot young stars. You see the dark dust inside this galaxy.
So
that
blue,
dark dust
blue is heat. It's
well,
hotter.
blue is hot young stars. Okay, hot young stars are the bluish ones, not the blue ones. The stars that are not as hot are more of a yellowish, orange, even red. Okay, every other star you see in this image here is here in the foreground. It's here in our galaxy, right? It's here, and those stars are way out here in this galaxy. The galaxy. These other stars you see are up here in the foreground. So this is the foreground veil of our own stars we're looking through.
Right.
To see this galaxy.
Our Milky Way.
We're looking at our Milky Way stars here, and then at some other galaxy stars 23 million light years from here.
But you can see it's kind of overlapping it. You could see these stars here that are like in front of it from our Milky Way.
That's correct. And we would have to study this galaxy to make sure these are in fact foreground stars and not just large clusters in the galaxy. Because there are stars that are star clusters that look like they might be in our galaxy, but are in fact in another galaxy.
Wow.
Yep.
So how did the Webb discover this molecule that they're talking about in the news that says that can indicate life on exoplanets? What was that all about?
I don't have the article in front of me.
It's a molecule they said that they detected with the Webb that could indicate it can be an indicator for exoplanets. But that's something maybe we can talk about on Monday when we come back from Roswell.
I also need to
do more research. Yeah, you got to look into
that
it
on our show.
Yeah, it's really interesting. Daryl might know a little bit more, but I think it was yesterday came out with it.
Yeah, I missed the announcement from the Webb team, so I don't know what the announcement was about. I thought it had to do with gravitational waves, but Izabela mentioned one thing in a chat earlier, and Daryl talked about it as well in our chat. Either way, it's all very interesting stuff.
It is.
The Webb is just killing us with all this new knowledge.
Mm-hmm.
Okay.
Give me a second, I'll take a look.
Daryl says he's going to look that up for us.
Cool.
I mean, I'm only doing 5 things here, so at once. So.
And I'm driving you nuts, jumping all over the place.
No.
Because I'm seeing it in person.
You're
it's
all
like
right. You're looking at it for the first time. It's
yeah.
really cool. But this is Measure 51, the Whirlpool Galaxy, and I'm going to save it just like this, and then save it exactly as seen.
Gravitational wave announcement is Thursday.
Oh, liminal. Thank you. Yeah, I mentioned the other day that I thought it was a gravitational wave announcement. And with pulsars, had to do with pulsars, and that's something that's very cool. Bonnie says phosphorus.
Yeah, I'm sure Daryl's on it, looking up the specifics.
Yeah, he is.
I haven't found anything yet.
Okay. I think it has to do with a pulsar and gravitational waves being detected from a pulsar. And that's actually quite cool. So that is the Whirlpool Galaxy. Now, see the spiral arms in this?
Mm-hmm.
They actually think that maybe this galaxy colliding with this galaxy defined these spiral arms by causing that density wave we talk about to actually form here. Kind of really very interesting the way that works out. But you can see some really good detail here, and we'll just zoom in one more time before we
that is awesome.
Here, we'll just go here. And then
You might point out to Bill that not only is the small galaxy affecting the big one,
That's awesome.
the big one is affecting the small one. You see the fainter stars all around it, kind of a dim cloud. That's where the small galaxy is being torn apart by the big galaxy.
Now, as Daryl rightly points out, if you look at this galaxy, this one sort of passed into its vicinity, and so it's pulling these spiral arms. However, this galaxy has also caused havoc in this tiny galaxy, because look at all these other stars being dragged out from it. Okay, these stars are all being dragged out from it. Look, you got a long line here.
Oh.
So this means this has actually orbited this galaxy more than once. It's
But
gone through this before.
It looks like, okay, so this one in the foreground passed through the one in the front, correct?
That one in the background.
Right.
Yes.
It looks like this was larger than the one that went through it, because it looks like this one got kind of washed away a little bit, or that's just an anomaly from the camera.
No, that's not. That's actually potentially that this was a smaller galaxy that went through the bigger galaxy.
And would that be an example of what happened to this galaxy since it was smaller, and an Andromeda-sized galaxy and this is what could be the remnants of what we would look like with our Milky Way after going through
It's
something
possible
like that.
that in 2 billion years that we will be the new Whirlpool Galaxy system. Because our galaxy might be like this small.
But it looks
satellite.
decimated, like it does. It looks fuzzy and it looks.
Oh yeah, you can see some dark material here. All this dark material that you see, this was formed in countless supernovae. Okay, number one. Number two, formed by countless red giants in their outer atmospheres. They're so big that they could form molecules, carbon molecules and silicon molecules out in their far reaches because it wasn't very hot out there. So
that's amazing.
It is pretty cool. I'll save this one more time. Let's save exactly as seen. Alright. And now okay. Heidi Gadd, thank you for coming, and I hope you have a good evening. Thank
Good
you
night,
for stopping
Heidi.
by. Bill says good night as well. Okay. So we'll.
I'm bailing soon because my clock is saying 1:35 a.m. for us.
Yeah, I agree.
You know what I mean? I only
know.
got 4.5 hours sleep, so
I
I'm
know.
like twisted.
I know this is going to be a short stream, but we're.
But
good.
you and Daryl, like I said, hopefully you're gonna do one from Roswell, obviously.
Yeah.
But hopefully we'll do another one before I go back home next Wednesday.
Yeah, I mean it's
'Cause this
hard.
is this
it's hard
is
to stay
awesome.
away from this.
It is. It's amazing.
It's hard to stay away.
It's highly addictive.
It is, and I'm gonna.
It is.
I have to just check something out here. I want to show
Go
you
for it.
one more thing.
Yeah, show me before I go.
I know you're not going yet. You stick around.
Yeah.
Don't you dare go
No,
anywhere.
I'm gonna go smoke.
You're
a
not
stove.
allowed to go anywhere. No.
Mark,
Yeah.
M13.
the molecule Bill was talking about is called methyl cation.
Okay.
CH3 plus was traced back to a young star system located 1,350 light years away in the Orion Nebula.
Okay. So you're talking about a special molecule that was discovered. That's a methyl cation. It's called. That's CH3 plus, I think.
Mhm.
Yes.
And so that's a positively charged pair of atoms. Okay. CH3 plus. Okay. And
The importance on the building blocks of life because.
yes. Well, because this methyl cation is actually important to the production of life. So this is a potential.
It's like a spark.
It's an indication of life-building molecules that are in existence out there.
Carbon molecule detection.
Yeah. CH3 carbon is in there, so it's carbon.
Got it. I got you.
Okay.
I pasted the link in your chat.
Thank you. All right. So
And,
now we're gonna. Oh, look
Pasted
at
a general chat.
that. We almost had a. All right. We're gonna just bring this into the center.
Did something just shoot across the screen?
Yep. That was. You saw a Starlink satellite come through.
Wow.
If you see a, okay, I'll just draw this just to show you, because at the distance that the Starlink satellites are, if you see a trail that's about like this, when we're zoomed all the way out like this, that's going to be a Starlink satellite. That's the typical speed that we see, right? And this is a 1 second exposure. At 1 second, zoomed out like this to 33%, that length is typically
Starlink.
at the altitude of Starlinks. Yep.
Wow.
Yep. And we've seen them so many times.
Yeah,
that
I've just seen it
every day. Yeah, I mean we can't shoot anything without us seeing
Finding
satellites
something.
now, unfortunately.
Yeah, that was amazing when you caught the meteor hitting
Oh yeah,
the
the
surface
meteor
of the
hitting
moon.
the moon was very
That was
cool during the lunar
outrageous.
eclipse, yeah. Yep. Yeah, Cosmic Ray also suggested what you said too, Daryl, about the
Yes, I see that now.
methyl cation. Yeah.
In the Orion Nebula.
Okay, so let's do. We're gonna wait till we start. We get our guide start going. You see up there, as soon as we get numbers. Okay, there's the calibration. Then it starts guiding, and we let it stabilize for a couple of moments. And now what we can do is a 15-second exposure of this guy, which is the Great Cluster in Hercules. That's not it. That is just me having to clear all this from the previous one. And now we'll see the first one, this next one right about now. There we go. Look at that. That is a stunning cluster.
That's like a glob.
It's a globular cluster.
Oh, it is?
That's what it's called, yeah. Or globular cluster.
It literally is.
It's a globe. That's so... And if we do this, we pull out a lot of the brightness near the center. Right, we can actually start to go in like this, and now we can zoom in on it, and you'll notice another interesting feature about this cluster, that there's a lot of stars that are red.
Yeah, I see that.
Yeah.
But the red is cooler.
That's correct, temperature-wise they are. But that means that they're not necessarily smaller. It means they could be red giants. Red giant stars, stars go into a red giant phase twice in their lifetime. The first after they run out of hydrogen, and so their cores collapse when they run out of hydrogen, and that collapse causes a lot of energy to come out of the center of the star, which causes the envelope of the star to grow.
Right.
And so now you have a red giant. And then that core continues to collapse, and at a certain point, the core reaches over 100 million Kelvin, which is a temperature scale, and that's when helium can start to fuse. And now we get the kind of like a rebirth of a new fusion fuel of the star, and the star begins to become bluer and hotter again. And so you see a change in its color and movement on our diagram that we classified on. And then when it runs out of helium, the core begins to collapse again, and the star begins to grow once more. And then we have another red giant phase that's called the asymptotic giant branch. But don't worry about that. The AGB branch just means that that's the final growth of the star before it becomes either a planetary nebula that's like the Helix or the Dumbbell Nebula or the Ring Nebula, or goes supernova if it's massive enough.
What are those greens?
Greens where?
You see like all these greens in there? They're like green dots in there.
Oh, let's zoom in because I don't think
you see all this is that blue or green?
Yeah, those are bluish.
So could that be what you're saying? Those orange could eventually turn into those blues in that cluster?
Not so much the blue. Once they go red, they might turn a little lighter, a different shade of red, but lighter, but then go back to red giant. So once you hit red giant, you're going to kind of always stay in the cooler end for a while.
Okay,
right?
but
you don't ever get blue hot again.
Oh, okay. That's what okay.
These
gotcha.
Stars,
that's the question I was trying to...
These blue stars you're looking at right here.
Okay.
Okay, these
Don't never
guys,
get that again.
And just to make it clear, too, just for people watching, okay, we see some bluish stars here.
Yeah, there's a whole bunch of them.
There. We see lots of them here.
Yeah.
Okay, and here. And then, of course, you see the red giants out here.
Yeah.
Okay, Daryl's pointed out red giants, too, in clusters like the
there's
cluster,
a bunch. Yeah.
Another place.
There's a bunch in there.
So these may also be red giant stars, yeah. And these stars here are evolving, and for all we don't, depending, and this is the complex part, depending on what isotopes we see in their outer atmospheres, it shows us where they are in their stellar evolution. Okay, if we see a certain amount of carbon, of certain carbon isotope,
you know what the phase
we
of it
know
is.
that it's in that second red giant phase versus
that's
the first.
Yes, gotcha.
Okay,
that makes sense.
It depends on the quantity of these isotopes and the ratio between them. All right.
And they can detect that from the vast
from the spectrum. Yeah, from looking at the spectrum of the stars, you can actually detect.
That's amazing.
The carbon 12
That's
versus
amazing.
carbon 14 and nitrogen. Yeah, and thus you actually can see, what is going on out in the star.
That's unbelievable. That's incredible, actually, when you think about it.
It is. It's very interesting how it works. Daryl, this is pretty.
Mark,
beautiful.
question: Is this
sure.
M13?
It is.
Because I see a propeller.
Yeah.
Because there's so much in there.
And now, do you see this feature right here, Bill? There's a feature, this long thing here, and then there's a little shape here, a little shape here.
Mm-hmm.
Looks like a 3-bladed thing here.
Mm-hmm. I see it.
That's what we call an artifact or an illusion, and it's called in some annals it's called the propeller.
It kind of looks like a propeller.
It is, and this is Messier 13. Okay. Now I haven't been putting the name
got 3
up here, but yeah, it's these 3 you can see the objects. Yeah.
Yeah.
Okay. So in other words, so this is Messier 13. All right. And it's a globular cluster. I call it a GC. All right.
It's about 300,000 to 500,000 stars in a ball about 150 light years across.
Yeah, it's about 150 light years across, as Daryl just said, and several 100,000
What was
stars.
that number?
150 light years. Wow. Yeah. And
wow.
Several 100,000 stars. Okay. Yep.
And
The
these are
finest
found
globular in
throughout
the northern
space?
sky.
These globular clusters?
What did you say?
They're found throughout space? I mean, we see these...
These globular clusters actually not
that common?
They're not throughout space. No, they're actually they're actually what are called halo objects. They're around our galaxy. They orbit our galaxy. People can hear the AC unit has
All right.
down again.
Okay, so wait a minute. Okay, I'm trying to follow this now. So I can't say the word.
Globular.
Please say it. Thank you.
Globular.
These are within galaxies themselves?
They're orbiting galaxies. They're called halo.
So they're on the
objects.
outside.
Yeah, but they'll pass through the disk too. You know, they'll pass through and plunge through the disk, and then go around the bottom and come up again. And they may drop off stars in the disk. They may gain stars.
So it almost sounds like a Kuiper belt thing within our solar system. Like they're just on the outside.
Yeah. Actually,
You know, that's an analogy.
I know
kind
the
of deal.
analogy you're using. The Kuiper belt
it's
has
on the
a lot
outside.
of icy objects, but these, of course, are not.
Yeah,
icy.
right. But I'm using
I
it
know
as
what
an
you're
analogy.
talking about.
It's on the outside, the peripheral.
That's a good analogy.
And then it interacts at times.
Yes.
That's
correct.
You might tell Bill, when we see Messier 13 here,
It's beautiful.
it's 1,000 times closer than Messier 51 was. This is
what do we got
22,000 light years away.
Okay. So this is, as Daryl was saying, it's like about 22,000 light years away, and because he looked it up to get us that data, and it's like 1,000 times closer than the galaxy we just looked at. Because keep in mind, this is a halo object that's going around our galaxy, orbiting our galaxy, and Messier 51 is a whole nother galaxy, 23 million light years away. This is really pretty, Daryl. Look at that.
It is beautiful.
Yes, it is.
Even with the moon out, we get some really nice views.
Yeah, I think this is why people
But look
love
at the
it so
density of so much in
Yeah.
there. There's so much in there.
There's so many stars in there. Now, if we actually let it decide where it wants to go, it'll show it like this. All right. But I prefer to allow us to see the color by stopping it down a little bit like this, and then allowing us to pull out some of the processing so we can see what's going on in the core. Like that.
So what's going on actually in the core? Is it pulling all this into the core?
Well, that's a good question, because one of the things that's controversial that we don't know yet is if globular clusters all have massive black holes in their cores.
That's what I was thinking. That was going to be the
causing
next
these
question.
stars to adhere to them, basically.
Tugging.
Be tugged by them,
Yeah.
We don't know.
Because that's a lot
That's
going
right.
on. It looks like something's pulling it all together.
And Bill says yes. It looks like something's pulling it together. Oh, you guys can hear Bill. Sorry.
I'm sorry.
And it orbits. They're orbiting each other, and if there's a high gravitational field inside that cluster, then the cluster would tend to not fly apart, and they don't. And we don't see them flying apart over time from interactions. They tend to stay in orbiting, and it could be because of a supermassive black hole in there at some point. Pretty cool.
It is beautiful.
This is the best globular in the northern sky.
Yeah, Daryl says it's the best globular in the northern sky. So it is
Look
for
at it.
sure.
It is. It's stunning.
Yeah. If you look where the telescope is pointing, let me move Bill and I out of the way here, up to here. Okay, you look down here, you can see that the telescope is pointing almost straight up.
Yeah.
So it's actually doing a nice job.
With the moon.
With the moon, yeah. Our filters are allowing us to correct. Let me correct this a little more.
I would love to see this when the moon is in.
Oh, yeah.
Oh, my gosh.
Bill, you can see this in the clear night. You just have to break your telescope out of the shed.
I'm gonna have to stay up late at night and watch SkyTour live stream and see you do this stuff.
I gotta tell you,
I'm not kidding you.
Daryl said
Oh.
you could see this on a lot of nights. You just have to break your telescope out of the shed and check it out.
Like I have time to do that one.
I know, right? Bill, of course, as you guys may know, is the KGRA producer,
Program director, and so he's got lots to do. Lots of responsibility.
Yeah, and so yesterday and today and tomorrow are probably one of his only days off in how long? Okay, yeah, that's
just, well, yeah. Let's just leave it at that.
I want to say hi to Curtis Horn, who's here. Hey
Hey,
there.
Curtis.
Good to see you, Curtis. Curtis is a longtime viewer of SkyTour live stream. He's also a very intelligent guy. Runs a lot of has a lot of good astronomy commentary. And used to have a group over on Cloudy Nights, which is where astronomers go to talk to other astronomers.
Yeah, he's helped me in the past.
Yeah.
He's the one that told me to get the filter, the night filter, for the Sony.
All right.
And it works great.
Yep. Izabela, thank you for the KGRA FM.
Yes, thank you.
Very nice, thank you. That's what the people who view SkyTour are fantastic. You know, they just, you know, they help everybody
It's
out.
a
You know,
global
how
community.
in the world can you just? How in the world could anybody have a bad thing to say about anybody? Okay, so this is...
And this is, we're all here to be educated, for me at least, it's education.
Oh, it's very cool. I mean, and I can't help but just look at this stuff and just marvel at it.
You're not only seeing these incredible images, but you're also being able to interact with somebody like you, an astronomer, and interacting with people with their questions and comments. Where do you get that, Mark? Come on. Nowhere.
I haven't seen it.
I mean, come on.
I really haven't. You know, and it is somewhat rare.
It's special. It's special.
I'm pleased that people enjoy it. I really am.
And of course, to have Daryl part of it too, because he knows. I mean, he's
Daryl knows what
another
he's doing.
one.
Yeah. Daryl knows what he's doing as well. You know.
42 years as an amateur astronomer.
He said 32 years, you said?
42.
Oh, 42.
Yeah, he's been doing it decades.
Yeah. I've been
Built his own.
I've been doing astronomy, started as an amateur when I was 9 years old. And then at age 9, I've told people this before, that's when I decided I was going to be an astronomer. At age 9, I looked up in the sky and said, we cannot be the only people out in the universe.
And you contacted NASA? What was it that you...
I did. I created a space. I had surgery when I was 9, and I had to be out of school for like 2-3 months, okay, because of the surgery. So what did I do? I came up with a space station plan. I sent it to NASA, and a scientist reviewed it and sent it back to me.
Yeah, I remember. You told me
And he
that.
put all these wonderful comments on it, and told me I should stick around with astronomy, stick with it. And he sent me mission patches, models,
That's so
books, a big giant box I called the space box. I had all kinds of stuff that he sent me, and it turns out it was like 42 years later I contacted him.
Wow.
And of course he didn't remember.
Right.
It was what it was, but he said, yeah, that sounds like me. And when you find out who the guy is, you find out that he's the head of all he's the chief engineer on all outer solar system robotic missions.
Wow.
His name is Gentry Lee at Jet Propulsion Laboratory.
Wow.
He was a NASA scientist, a junior scientist back when I sent him that plan. And he took the time to make all these comments to this little kid he never met before. And he spent the time to encourage me. And that clearly shaped my future.
No doubt.
Yeah.
No doubt.
Yep. Yep. And at the same time, my parents received money from a family friend who, his name was Joe Watkins, who gave them money to buy me a telescope because they knew that I was into telescopes and into astronomy. And so those two things together sealed my fate.
And I'm sure you're probably doing the same thing right now to somebody young that may be watching right now.
Absolutely. I mean, so many people like Lane with Daisy and Zoe,
exactly.
Darlene, Elisha Beers. I mean, and there was a little girl whose name was Noah, and she was at Pine Bush, and she sat there, and her mother was taking out her wallet to buy a book, and for her daughter. And her daughter says, "I know about black holes." And I said, "Oh, let me hear. Tell me, Noah."
That's cute.
And she proceeded to tell me all the things about black holes, and she was absolutely correct.
Wow.
How could I charge her for a book?
That's a future astronomer.
Oh, I wrote her a
who
nice
knows what?
I wrote her a long paragraph in the book, and I said, "This is for you. Put your money away. You know, you earned this book." So I thought that was really cool. You know. So I mean, you got to do that because you know what? I've always say you don't know who you're talking to.
Yeah.
You just don't know who.
And how you impact the life.
Yeah. You
It's.
don't know who you're talking to.
Daryl, don't talk about heat because I'm freaking out. It was 106 or 7 today. It was like, oh my god, this is heat.
Hey, that's because of your comment in the chat.
Yeah, I see Daryl's comment. I'm like, oh my gosh.
We get a spell of hot weather before the monsoon touches now.
But like Mark said, I wasn't sweating. I was never sweating.
No.
It's just.
It's a dry heat.
It's hot. Yeah, the sweat evaporates. You are sweating, but the sweat's evaporating off your body faster than you can feel it.
The humidity was like, what, 6%?
Mm-hmm.
I mean, that's...
Yeah, humidity today was 6%. You get out of a shower, you could use a dish towel to dry off.
Yeah, it's evaporating.
It's gone so quickly.
Yeah.
All right, let's... I want to do one more object tonight. And...
Snickers.
What shall we do here?
That's a good dog.
Yeah. I don't want to look at another globular. We did that. Let's see what else is up here.
Fantasies like it gets way hotter.
Yeah, that's right. Let's go over here.
What's...
Wire's up. You can do the ring.
Yeah, the ring is small in this telescope. We can try it. Let's actually look at the elevation. It's high, more than high enough. Wait, for cosmic ray, we should do the Cygnus star cloud. Curtis Horn says...
Maybe you could do the dumbbell. It's right there in Vulpecula.
Yeah, I was thinking about that right now. It's also high enough, I think. I want to just mention, Curtis Horn says they were at Star Arizona 2 weeks ago, and my daughter bought me Father's Day present. They gave her 2 books, and she was very excited. Yeah, they are a very good shop. You know, Dean Koenig at Star Arizona, David and Scott, all the people that run it are great. They've been instrumental in helping us get our business and our observatory out in the desert up and running. So no doubt about it. But now, you know, Curtis, I gotta know, what did you get? What was your Father's Day present? I want to know. Inquiring minds want to know. So, hey, Lewis. Lewis is with us. Oh, okay, let's see. Encryptasia, how you doing? Saturn and Mars is not available right now, actually. Saturn is set, Mars is not up. Now let's, it's not this guy, this is not it. But let's actually do the dumbbell. Do an early Dumbbell Nebula. Actually, it's M27. Yeah, this is a good one. This may be right on the edge, Daryl, but we'll try it.
Okay.
It's going to be way up in the northeast.
Excuse me a moment, please.
Sure. Oh, sure. Hit and run. Suggest an object and disappear. All right, no problem. Curtis says he's a Newtonian guy all the way. Excellent. Okay, let's... I'm at 116%, so I want to get down here to 33% because there's a dumbbell. This may have worked.
Wow.
Yeah, this is a beautiful little nebula. Wait until you see how this looks. Now, in this, and it's a little, it's kind of low, and I might have a little bit of impact from the building wall, but maybe not. We'll see. Maybe not. There we go.
I could almost see the dumbbell already. There's one circle on one side and the other one's in the other side. You could see it.
Yeah. All right. So we're gonna search now for. We're doing our. As I said before, we're doing our guide star here. Alrighty. Okay, we're guiding well, and this will be. This doesn't have to be very long. This one's going to be a 12-second exposure. And this usually gives us all we need to see. So we'll get out of night vision mode and go into our live stack. Oh, we can get rid of this guy. And now, in just 1 second, there we go. There's our dumbbell. And let's zoom in on that. And you'll see a star in the middle there, that little dot right there that you're seeing. I'm going to color correct here a little bit. There we go. You can see it right in there.
That's it.
That star is known as a white dwarf. And so this particular star kind of sloughed off its outer layers as it ended its life. Remember I talked about stars that become red giants twice in their lifetime? This star became a red giant once and then twice, and it actually started puffing off these outer layers, because once it becomes these red giant, particularly in that second red giant phase known as the asymptotic giant branch, they start to do thermal pulsing. And the thermal pulses can last like 10,000 years and go through several of them. And
so is that what creates the dumbbell effect?
Yes, that's what creates this shell of material that comes off. Okay, and as you can see,
pulsing.
Yeah, it was a pulsing that sent this stuff off. I'm gonna just do a little bit of this here. Okay.
So eventually, will the pulsing end and it's going to change appearance and then go supernova?
No, once it's a planetary nebula, is like the fate of the sun. The sun will never go supernova. It's not massive enough.
Okay.
Okay. Stars that make a planetary nebula like this, they don't go supernova.
Gotcha.
They actually just do what you see here, and that's all they ever do.
And then what happens after? That's like, is there
There's a nebula that's slowly expanding away from the star, and as it slowly expands away from the star, eventually the star in the center is cooling down. The white dwarf isn't doing fusion anymore, which is the energy of stars.
But will the pulsing stop?
Well, the pulsing did stop, and the pulsing stopped after these outer layers were all blown off like this, exposing the core of the star, which you see right here. A little tiny thing, and it's a little bright. I could have done actually a little less exposure. Let's see if we can do this here.
So I have to ask another stupid question. Is it shrinking in size, the star?
The white dwarf reaches a certain size. What were you going to say, Daryl?
Well, go ahead.
The white dwarf reaches a certain size,
Is it very dense or no?
It is, and we kind of know a lot about white dwarfs. They seem to all go to the same size, which is about the size of the Earth. And they all seem to have around the same mass, maybe a little less, but their maximum mass they can have is 1.44 solar masses. That's it. You can only put that much stuff in there, and if you do that much stuff, it can't collapse any further to become like a neutron star.
Gotcha.
Okay? Any more mass than that, and it can become a neutron star.
That's what I wanted to know.
And sometimes in binary systems where you have a red giant and a white dwarf that already evolved to a white dwarf circling them in the orbit, sometimes the gas from the red giant, because it gets so big, crosses over the boundary between the gravitational fields of the two, the white dwarf and that red giant, and it spills this extra gas onto the surface of the white dwarf. Now, if the white dwarf is 1.2 solar masses at that point, well, then it's okay. But if it is 1.4399 and more gas spills onto the white dwarf,
it could explode?
Yes, something catastrophic happens. And it's a special type of supernova called a Type 1A.
Wow.
And so we see those. And Type 1A supernovas are characterized by the spectrum that they give off. In their spectrum, you can tell by looking at the stuff.
I would never have known.
No. And that spectrum that it gives off is something that will tell you what it is, the Type 1A supernova. And because they all happen the same way, they all have the same kind of brightness. So, if we see one that occurs in a distant galaxy, we can calculate exactly how far that galaxy is.
Are we improving on the spectrum analysis with the technology that we're at? It's always evolving.
Absolutely, yes.
So we're obviously going to learn more and more.
Oh, yes.
And detect more.
And we are. We are. Let me drop this color a little bit here.
I'm sure they had to add all this on the web, right?
Yeah, the web does a lot of things like this.
Yeah, because it has a lot of equipment on.
Okay, so here is this dumbbell, okay? And what's interesting about it is that blue object. You see that blue?
That's it in the middle.
That blue thing in the middle, you know what that is?
The dwarf star?
That's the white dwarf. Yes, it is. Now you say, well, wait, it's blue. Why are you saying it's a white dwarf? Because the white dwarf is the name of what this is, okay? But it's actually a very, very hot star. The remains of a star. It's a core.
Right.
It's not doing fusion. It's a hot core of a star that remained after all those layers got pushed off by the star's core. And that hot star in the center will eventually cool, but not for billions of trillions of years. So that blue color is because it's hot.
So it will turn yellowish red.
Eventually.
In billions of years.
That's right.
As it cools.
Maybe trillions of years.
Wow.
But because it's so blue, a lot of the energy it's giving off is in the ultraviolet energy range, and that ultraviolet is hitting oxygen atoms out here in this envelope of material here, and hitting hydrogen atoms out here.
It's interacting with all that.
And it's interacting, and it's ionizing them and causing them to glow.
That's amazing. That's beautiful.
And what's interesting is, we know how white dwarfs work. White dwarfs can only ionize out to a certain distance. So it means that if the nebula has other gas, if we can see a boundary between an outer edge and more gas, like oxygen atoms out here, or hydrogen atoms, by mapping the nebula, if we see that boundary where it's not ionizing anymore, we kind of know how big the nebula is in light years, and then we can get a distance to these things. But the distance to planetary nebulae is notoriously difficult to calculate because of that problem. We don't know if this is finished expanding yet, or if there's more stuff out there.
But I'm sure are there other examples that can be used in reference, like to what you're seeing right here?
Well, each planetary is different, so we don't know.
Right.
You know, we don't know if this one's expand to its limit, or if it's still able to expand more.
It's not like the identical properties are existing somewhere else, and the same things are happening.
Everything's different.
Right.
Let's say that this is hydrogen right out here, and oh, hey, look at that. Now it's expanded out to here. What kind of gas is out here? You know, a study of the interstellar medium out here could tell us whether there's more hydrogen that isn't excitable, and out here maybe there's oxygen atoms that aren't excitable.
But that's because of its reach.
That's because of the reach of that white dwarf star.
Right.
So if that white dwarf star could possibly heat this stuff up to glow, it would have. But if it can't, it shows us we're at that maximum limit.
Right.
That maximum limit is between 1 and 2 light years. So if this was 2 light years across, we can then figure out how far away it is because we can measure how much space it takes up in the sky.
I get it.
And calculate using an equation. I've done it too. With the small angle equation, we can figure out how far this thing is. Even using that.
Even with the spectrum of light, you can see.
Yeah.
The different properties.
Oh yeah. That's all we have is the light.
Yep.
Daryl, look at the bottom, Daryl. You see that beautiful red at the bottom?
Oh yeah.
Yes.
Yeah, Bill's pointing to it now. He's pointing to this area down here.
Lewis pointed out in chat.
It almost looks like a pole on a planet.
The
that big
ultimate
area.
fate of a white dwarf
That's
is to become
beautiful.
a black dwarf. Not a black hole, but a black dwarf. When it cools off, it'll just go black.
Yeah, that's the Lewis pointed out I'm telling you, Bill, because you didn't hear it. In chat, he talks about when a white dwarf finally does cool, it becomes a black dwarf. We don't see any black dwarfs yet because no white dwarfs in the history of the universe have ever cooled to the point where they become black dwarfs.
Gotcha.
But eventually they may, or they will.
In
eventually.
time, with observation.
In time. But we'll never see it
Lots of
because
time.
the universe will probably die before a black dwarf actually is created. But isn't that pretty? That's really nice. I think I got the enhancement on here. I do. If I turn it off, you can see what happens.
Ask Bill if he sees an apple core.
Yeah, he mentioned he sees kind of a shape here, like poles. This particular nebula is known as a bipolar nebula, and that means you can see it has a distinctive lobe shape to one side and the other. Okay, I'm gonna guess that the star orbits, on this, like the South Pole and the North Pole is here, and this is the equatorial region, and it was going around and around and around. And as it was shedding these layers, they came out from the equator as opposed to the poles. Okay, and so I think that's what happened here. So less stuff came off on the poles. So really, if I had to draw it out, I would say that this is probably the line of, say, like north to south, and this is the equatorial line.
Because of this?
Yeah, because these lobes right here that you're seeing, this is the material that would be thrown out along the equatorial region. And then this is sort of off a little bit. Sorry.
It's oval. It almost looks oval.
Yeah, that's right. So that's not a good line.
It's like it's stretched.
Exactly. So it would be kind of like
this. Yes, I see that.
Okay, and this would be the north-south line, and this is the east-west, spin. So the spin would be around this axis.
To give it like the equatorial line.
Actually, the spin would be around this axis, meaning that it would spin this way.
Okay.
Whipping around this way. And
it's unbelievable.
Yeah, the bipolar nebulae, the way they look, could be related to how fast the progenitor, the star that caused it, was rotating. Some stars are slow rotators, and some are very fast rotators. Maybe fast rotators cause bipolar explosions of nebula like this. Lewis says the Chandrasekhar limit is the one where the white dwarf star gets big enough to go type 1 supernova, right? Yeah, that's correct. The Chandrasekhar limit is 1.44 solar masses. Now, when a star goes into the red giant stage and sheds its outer layers for the second time and becomes a white dwarf, that white dwarf will, of course, the core collapses. And if it's less than 1.44 solar masses, it stops at a certain point and doesn't go any further in its collapse. That's where a process called electron degeneracy takes over, And the electrons, like just imagine a checkerboard, and in each square you have one electron, and you can only have one electron in each square. You get that checkerboard full of electrons, it cannot be compressed anymore. And that is an example of sort of an analogy as to how electron degeneracy pressure works. Now, if the core is more than 1.44 solar masses after this ejection of material, a more massive star may have that, then the star can continue to collapse past electron degeneracy. But then there's the next barrier that it meets, and that is where you have neutrons that are in all those checkerboard squares, and they can't be collapsed anymore. And so we have, as you might guess, neutron degeneracy pressure, which keeps the neutron star in check. And so it keeps the neutron star at that particular size, and that's how neutron stars are formed when you go past that. And that works to about 2 to 2.2 solar masses in the core. Beyond that, the collapse can continue even more and take us to the black hole range.
You know something, like I just got super educated just from this hour or so spending the time with you. This is why folks that are watching, this is why this is important. And you can donate. You can get the shirts, $25. But like I said, Bill's number one. I got the first one.
Oh yeah,
I'm gonna say that forever. You know that, right?
Yeah. So, these really do look good.
They are nice and they're comfortable.
They are. These
They're
haven't
like
even
a
washed yet,
smooth.
and they're fine.
No, but they have like a nice comfortable feel on the body.
It's very nice, yeah.
But Bill's going to bed because I can barely keep my eyes open. It's like it's 11:15 here, local time, but in the body it's 2:15.
Yeah.
We had a long trip, but
yeah.
as always, thanks to Mark.
I got up at 3 o'clock this morning
So
to
did
come
I.
out here, and it's I
Oh
guess
my God.
let's see, from 3 o'clock to now. That's a long time.
It is.
I think we've been up till 11 o'clock tonight.
24-hour cycle.
Yeah.
It's like a 24-hour cycle right now.
Yeah, but I this stuff turns me on. I can't stop. Let's get rid of all those red.
Well, you got Daryl to hang out with for 3 more minutes. But everybody, have a great night. It was great being a part of SkyTour live stream, and definitely Saturday night he's going to be doing it again live in Roswell. So tune into that, and hopefully we'll do another possible stream maybe Monday when we come home, depending how tired we are.
Hang on now. I got to do one more thing.
Okay.
Looking at this nebula, there's one thing, and Curtis Horn hits
Brought
this.
it up.
He mentioned it, and I've said this in other streams. I want to mention this. Okay, we talk about these red pieces here.
Yeah.
And what do those mean?
Yeah. You were mentioning that earlier.
Okay. Well, let's go back to our north-south orientation on this thing. Let's say that this is like a north pole and a south pole, and it rotates around this axis like this, right? Okay. What if this axis isn't staying straight? What if it's doing this? Okay, what if it's
like a wobble?
Yeah, it's a wobble, like the Earth does precession.
Mm-hmm.
What if the star is doing precession as well? And they can. All right. That means that as it's sloughing off layers, you might get concentrations, like down here, and it stops, and up here it seems like it goes in an arc, doesn't it?
Mm-hmm.
Seems like this goes in an arc, and it seems like there was some kind of event which caused this little jet.
Yeah, I was going to say that. It looks like a jet.
Yeah, that could actually be something that was caused by a discontinuity in the interstellar medium, something in the interstellar medium that it collided with on the way out, perhaps. But if it precessed and went like this around that red line, then it could have caused this strange shape here, and of course made a bipolar nebula. So I just thought I'd throw that out there, and thank you, Curtis, for reminding me of that, because that's something I did want to mention. Yep. Very good. Well, guys, this is cool. I'm going to save this. I'm going to make a note of this here. This is Measure 27.
Don't forget, folks, Saturday.
Oh, yes.
9:30 Roswell time, which is Mountain. So 10:30 Central, 11:30 Eastern, and oh my God, 8:30 Arizona time. Oh my God!
Yes.
I think I got it right.
You did. And the thing is, we will be that's going to be when we're doing everything. You should go on the Roswell incident webpage.
Yeah.
And look for the times for everything.
Yeah, it's Roswell incident, not the Roswell incident. Roswell incident, because I made that mistake and got in trouble. I put the Roswell. Nope, Bill, that's not it. It's Roswell incident.
Bill's always getting in trouble.
I'm always getting in trouble. Mark, thank you so much for having me.
Right,
and Daryl, always a great job as always. And everybody in chat and those in watching, have a great rest of your night, morning, and we'll do this again soon. But don't forget about Saturday from Roswell.
Yeah, absolutely. So,
Mark, I'll see you in the morning.
Okay,
I'm
there
going
we
to smoke
go.
quick, and then I'm going to bed.
All right, guys. So that was kind of cool. We actually got to do the dumbbell here. Neato. Hey, you have to stop reading my mind, Izabela. I was wondering if we could get to the Lagoon Nebula tonight, but I'll have to go look and see where it is. The dumbbell's looking beautiful, so I'm going to save this. We've got 88 captures here, beautiful guiding. Save this and save it exactly as seen. There's a lot of stuff out here that isn't visible. And we do have a moon out, so it tends to increase sort of the contrast of what we see here. Alright, so now I just saved it. So let's get rid of our stack here. And for those of you that wonder, if you go to skytourlive.org and scroll down, you'll see Take Me to Cool Pictures. And what that does is it'll take you to where these images that I'm saving are located. You can get these images and download them. They're all yours. Just go ahead. Alright, and I'm going to go back into our 1 second night vision mode here. There we go. And we're at 120% on our sensor. I'm going to go back down to 33%. There we go. That's almost the full screen. That's 4 full moons across, 3 full moons tall. Okay. So now that we have that, let's see if we can look at this. If we can't, we can't, and we'll call it. But I absolutely adore our beautiful nebulae that we see. So let's go see if we can do this. Oh boy, I think we'll be able to do some nebulae, that's for sure. Oh, see, I'm getting excited about this. Here we go. Okay, let's try it. This is gonna be close. This will be the Lagoon. I'm gonna put my mic where it's a little better. So hopefully this is better and you can hear me a little better. Telescope's on its way. Oh, look, there's the Lagoon Nebula. Izabela, thank you. That's a great idea. I'm not getting any sleep tonight. Jeez. Oh yeah, look at that. And there's more to this. Now the moon's out, so we're not going to see all the detail that we like to see. But and I'm going to move it because to the left side up here, we have something really interesting. We have the Chinese Dragon Nebula in addition to the Lagoon. So we'll move the Lagoon over here and then move north a little bit. Chinese Dragon's up in here. And for years I was looking at the Lagoon Nebula and not realizing there was this whole other beautiful nebula associated with it. But we'll try this. Let's do let this get stabilized, and we're going to make this a 25-second exposure. Once we start guiding, here we go. We've calibrated to 0. Off it goes. All right. Thank you, Izabela, for putting up the links. I know, we looked at the dumbbell tonight, Izabela. Okay, let's go check it out. And we'll say this is Lagoon. All right, and we'll stack? No. And we're gonna clear this. Okay, and wow, look at that. And of course, because of the moon, we have a little bit of a bluish tint to our imagery, but we can do some color correction and help get rid of that, and then do another correction. And now look at that. Wow, look at that. So here's the Lagoon Nebula, and here is the Chinese Dragon Nebula. Look at that. Ah, that's beautiful. It's really pretty. All right, let's see. This is what happens when I don't have anyone to tell me to go to bed. How pretty. Curtis says, very nice view. It is, Izabela. It's glowing with all its beauty. And we can actually, this nebula is powered by a very bright O-type star, which is right in here. I'm going to try and show you that O star, if I can show you. I don't know if I can. And the way we're going to have to do that is I gotta first of all take this out, and let's drag this way down, and then right in there, that really little bright spot in there, okay, that is a little hourglass shaped object. Let me see if we can zoom in on it. You can see it very, Daryl said he lost his net and he is still streaming. Yes. I'll call him back. I apologize ahead of time if you have to hear the Skype stuff. Alright. Maybe you won't. It's ringing. He's not answering. Are you back, Daryl?
Yes.
Yeah, there he is. Okay, great.
Share screen?
Yeah. And we're doing one more, and it turns out we're going to be doing the Lagoon Nebula.
Okay.
There it is. And I was showing the this beautiful area here that fires up the lagoon, the O star that is powering it. Okay, so now let's bring back, show you all the detail, and we're gonna go into the log of this here to try and show it. All right, and we're going to start it over again because it wasn't quite stabilized. So we'll do that again. No, the stars were elongated a little bit. That wasn't good. Yeah. Okay, let's go see. Shall we? Okay.
Hello, Mark. Am I live now?
You've been live.
Oh. Hello, everybody. Sorry, I lost my internet.
Yeah, I just brought you right back in.
Yeah.
Okay, so if we
Bill,
zoom out of this.
Bill gone now?
Yeah, he decided he had to go to bed.
Yeah. Oh,
What a
his
wimp.
loss.
I know, right?
First Lagoon for the season.
It is, and the first Chinese dragon.
Mm-hmm.
Yeah. This whole region is just filled with nebula. And if we zoom out, you can see here in this one shot. Actually, why don't we take that out, and let's also dump our stack here and just focus on this. Here it is. Look at that. Okay. What a pretty photo. And let's just see how much data is in there. We just start to go through this. Let's also, it's going to blow this out, but I want to see how much more data there is. Ready? Watch this. Okay, so you see all this other stuff down here. That's pretty cool. And this is at 200 gain. Look at that. That is so delicate. Isn't that? That's delicate. Look at that. Amazing. Ray actually says you should save the image of the generator star. Yeah, I can do that too, because not everyone will be able to have the capability of reducing the intensity like this, but anyone can if they knew how to do that. And I'm actually toying with an idea of teaching people some image processing that they can do on their own. Okay. So what I'll do here is, this is an image of the generator star. Alright, and so what we're going to do is save it. Alright. And
Generator star.
Well, yeah, the progenitor, the star that's actually...
okay, progenitor.
Yeah, the one that's energizing this nebula, actually.
Right.
Because it hasn't gone supernova yet, so it's still a star. It's still an active star. Okay.
Do they think it will supernova?
Oh, certainly it will, because it's an O star. And that's the fate of O stars. They all go supernova, and they all put elements back into the periodic table. Yeah, Izabela says so much stuff in the background. It's a beautiful image. It is. Let's see if we can actually get a little more clarity out of it. How about that? Now, look up here. Look at this beautiful area here. I'm going to point it out to you. Okay, it's right here. You see a subtle, the upper left, see the subtle shadow up there? So up here we see this subtle shadow right here, okay? And that subtle shadow of this object here is just beautiful coming down here. Really something right there. Wow. I like that. And then down in here, we have this subtle ribbon here. See this subtle ribbon? It's right here, this subtle ribbon right there. Moving through here. Right there. That's a very subtle, beautiful ribbon right there. And that is, of course, from the Chinese Dragon Nebula, which actually is the feature that gives it its name. Pull that away. Wow, nice. This better picture than the last one. This is good. Okay, Lagoon Nebula, and only 13 saved, only 13 here, so we'll save it. Save exactly as seen. Wow. Indeed. Okay, that's something else.
Nice pick.
Yeah.
Pretty vivid.
The moon does that, you know. So let's put that out there. So this is the Lagoon Nebula right here, and you can see that you almost can't put this anywhere and be able to still read it. Wow. Okay, let's bring back the telescope now. There it is right there. And let's dock our view again. So come up here and dock our view. Move our name. This is Lagoon here. And this whole thing is the Chinese dragon. Really something else, man. And there's more down here, as you can see. Very cool. Well, there'll be more to see on another night as well. Get rid of the name here. Alright, let's, there's been 18 saved here, now 19. We'll go to 20, and then we'll save it. You can see the subtle nature of the nebula right here. Let's zoom in on that just for a sec. This is ionized hydrogen that's being powered again by this O star in here, and plus some others perhaps. But you can see how this gas here is close enough to the star to still be ionized at several light years away. That's pretty good. That's why if there was a supernova near us, it could affect us from several light years away. And I read a paper the other day actually that suggested that maybe a supernova within 30 light years of us could be disastrous for us because it would attack the ozone, destroy the ozone. But still, pretty cool.
That guy on PBS Space Time, Matt O'Dowd, I think his name is.
Okay.
He did a program about that recently on YouTube. How near would we have to be to a supernova to cause damage or destruction here on Earth?
Mm-hmm.
He was saying, he posited a couple of different scenarios.
Yeah.
I don't remember a lot of the details, but I think it was, he thought farther, like 100 to 250 light years away.
I think it's highly dependent on the kind of star and how powerful it is, what its size is. You know, because I think if it was a UV Scudi, if that went off, and it will someday, and it was within 30 light years of us, it would incinerate us. And 100 light years away, it would probably be mass extinction. You know, it's one of the biggest stars in the universe.
Yeah, he talked like we really don't have much to worry about. Not not in any near time anyway.
Correct, because in our case, we can calculate the orbits of stars that are coming toward us, and which ones are coming toward us, which ones are going away from us, etc. And that's one of the things that we do, and figure out that certain stars are going to be coming more toward us over time, and others will not. And that's very important to understand. And those won't be of any significant concern for us. Look at that beautiful nebula. Wow. Okay, we're at 26. I'm going to save this. And save exactly as seen. And okay, we're going to do more of this as summer approaches, guys. So much to see, so much to do. Oh my gosh, you can't imagine. So, I'm going to call it for tonight. It is 2:39 for me and mentally in my body. And it's 11:39 here in the Arizona location. So we will talk to you another night. And the comments show just how much you guys understand. You're all very intelligent folks, and I want to thank you for adding all of your thoughts and commentary. I've been reading some of it. I can't respond to everything. But thank you guys, Cosmic Ray, Gladys, Izabela, and the others who are saying cool things and good things. All good. All very good. Lewis saying some neat things. Man, you guys are right on the money. So I appreciate it. And if I missed your comment, I totally apologize. You know that I don't mean it. Anyway, I am going to go to bed. I've been up since 3 o'clock yesterday morning without sleep. And flew all day today. And then went all night going to this. So I'm approaching 24 hours. I think I better get some sleep. Anyway, you guys have a good night. And I will talk to you really soon, okay? And look at this. Look what we got coming. We've got summertime approaching, guys. And man, I can't wait. I can't wait. We're going to do studies of these nebulas, I promise. All right, folks. I will see you later. So
Good night, everybody.
I was going to say good night, Daryl.
Good night, Daryl.
Yeah. All right, guys. You have a good night, and we will talk soon, all right? Bye-bye. Wow, this is something, huh?